Hello and welcome to the channel. So we have a Fender Champ, a tweed Champ. Obviously it's a reissue, it's not an original one, but still a nice amp nonetheless. So I saw this in the shop and I decided I'd snaffle it for a week. So we're going to check this over and just have a look at it. Just thought it might be good for the channel, rather than have a repair, just have something that, you know, we can look at and take to bits. Just have a look inside for anyone that's not, you know, seen one of these reissue Champs. So this is supposed to be hand wired. Let's swing it round on the back and just have a look. And there you are, you can see there. Oh, looks like the must be the grill's missing there. Couple of screws. Not fussed about that, are we? Right, let's we know this works okay. The only thing it does have is the dual lights flickering apparently, but we'll just have a quick look at that. It can't be much, can it? But it's not really a repair. Just right, so I've got the back off and I'm just looking in here. Looks to be like some work's been done to this amp. Don't know. So we've got a spray here, and then we've got a couple of sprays there. Then we've got an IC cap there. We've got a spray bypass capacitor, and those look like they've been changed to me as well. I don't know whether they have or not. Let's have a closer look at the soldering. It looks like it's been done okay. I was just a bit surprised. Ruby tube sockets there, so it is hand wired. 470 ohm screen resistor on the output tube. So look what tubes we've got. So that's the rectifier tube, and that's a Slvaynia. It looks like a 5Y3 to me, that does. And then we've got Electro Harmonics, is that 6V6? Just get the bear trap. Wow, I hate those bear traps. 6V6 GT Electro Harmonics bit with the groove tubes label on, so that's obviously been changed. Looks a bit singed, whether it's been singed in another amp. Don't know. What we got in here, let's have a look. That's a Mazda 12AX7, so Lee will have put that in. So he's got quite a few of those. We purchased a load of those, so he's probably changed that out. So I don't know what was in that originally. Nice preamp tube there. That's okay. And Slvaynia, yeah, pretty good. So yeah, it's had some work done to it, definitely. Pretty sure those weren't in it for as original. Why you'd leave the 22 microfarad IC cap in, though, I'm not really sure on that one. But yeah, that's about the only thing I can see that you know, flags up really. Seems to look okay. So we'll just have a look at the fascia plate on this one, and it's just a simple volume control on these, and that's all they need. These are a brilliant sounding amp. So let's have a look at the speaker then, so we can see. So we've got a special 8 designed Fender speaker in there. Don't know what that's like. Lee says this sounds really good, so we're going to be plugging it in and having a listen. Let's have a look at the transformers. So we need to just whip these two top bolts out. Right, so we've honed in on that speaker, and it's designed by Ted Weber, and I can tell you those are absolutely excellent speakers, the Ted Webers. So the Champion 600 that that I did on the channel. And that has a Ted Weber speaker in, and it sounds phenomenal. Really, really like those speakers. So yeah, so that's the speaker. We'll just ease out there. Cabinet's made of pine by the look of it. Yeah, as we can see there. So that's that looks nice. Nice bit of kit. Let's have a look at the transformers then. So let me have a look. So yeah, probably not quite as big as the original Champs, the 57s and so forth, but it's still nice. Small output transformer there. Not bad. Right, so we can have a bit better look inside now. In there, and yeah, it does look like I don't know, they might be original. It says IC on those, but the sprays, yeah, they've been changed. You can see the flux from where they've been soldered in, but they're okay. They've been, but I don't know why you change all those and leave that. So in fact, we could probably change that, couldn't we? It wouldn't only take 5 minutes just to swap that. Methinks. Diode there on the Slvaynia, on the 5Y3 there. Look, what's that? 16 microfarad. That's Sprague Atom, 16 microfarad. We have got so 16, 8 and 8, and then we've got this 22. So what's the deal with that? So I think that's the bypass capacity, you know, because that's node 1, that's node 2, because that's the red wire there, that's going to the screen, you can see. Let's get a pointer and do a bit of pointing. So this is node 1, and if you're familiar with this Champ schematic, and I bet a lot of you are, because you probably built, even if you're not, you know, doing this for a living, if you've built small amps, most people usually start with a Champ design. So we've got the 16 microfarad node 1 cap here, and that's center tap, that wire there, because that's coming down from the transformer if you look in there. And then there's the 10k drop-in resistor. That's node 2. Then we've got a 22k drop-in resistor, and then we've got 8 microfarad. So that's got to be the cathode resistor, cathode bypass capacitor. So who's put that? Why has that been put in there? 450 volts for a cath. Must take it a week to charge that up. Right, we've got this running. Pretty quiet when the volume's turned down. Right, let's see what voltage we've got going across that cap. So I've just looked in my stash, and I don't have an axial 22 microfarad. Only one of this size. I've got them in the radials, but we're not putting that in, are we? Don't put radials in these amps. It's just not done. 20 volts going across that. 20.3 volts, which is about what I'd expect. So 50 volts would be ample for it. It's 35 volts. 22 microfarad, 35 volts would be perfect for that. It was a 15 volt winder. But yeah, all seems to be there, doesn't it? Just that capacitor really, that if, you know, needs changing. I've had the pilot light out, and I've changed the not changed the bulb, I've just cleaned the bulb and cleaned the socket. It doesn't seem to be flickering now, so I don't know, but I think Lee says it's when you're playing the guitar through it, it flickers a little. There's a couple of fuses there we need to check just to make sure they're right. In fact, 3 fuses. I've just spotted another one. So that's good. They've not been stingy with the fusing. So yeah, it looks quite a decent little unit. The only thing, as I say, the only thing I can see is that bypass capacitor there, that IC, such a large voltage as well. Everything else looks there or thereabouts. What we got going over that 10k, about 40 volts. Let's have a look. 53.3, a bit out with that. I've actually got the current limiter on, but so although I've got the big bulbs in, so it's not dropping that much. Let's see what's across this resistor now. 21.5, so they're only dropping 1.5 volts there, not much. So look what's across this resistor now. Oh, it's a bit getting in here. It's not tricky. 57.4 across that. Yeah, there's not a lot. 0.32 of a watt. Let's see what's going across them when it's cranked though. Again, that looks a small resistor, that does, for with a drop-in resistor on there. Right, I've got it on the just got it up on the scope now. Just let it warm up a bit. Need to just drop that 5 volts per division. Starts to break up about 4.5 on the volume, and pretty quick when it goes. It's 5 volts per division. So I've got 4 watts coming out of that, but I have it on a 16 ohms load because I'm using the hot plate as a dummy load. So I've got 4 watts coming out there flat. It's about right. It's not far out, that isn't. Get a bit less at 4 ohms. Not sure what that Ted Weber speaker is actually. Well, let's have a look at that. Right, now it's swaging flat out. Let's just have a look at that 10k resistor again to be more careful going in here now. Right, got 179 volts going across that resistor. Now it's flat out. .2 watts is going across that resistor. So they must be really good quality resistors, because that's, again, just looks like 1 watt. And certainly don't look more than 2. But it's got to be more than 2, otherwise it would have gone up in flames by now. Because there's 3 watts, that's 3 watts going across that resistor, 3.2 watts. If we do the maths on that, this is 179 squared divided by 10,000 ohms, that's 3.2 watts. So they're pretty good resistors, and you have to check these things because it's amazing how a lot of amp manufacturers don't get things like that right. I know with some of the Marshall Origins, some of the drop-in resistors are under spec, and it was Lyle Coleman that actually found that on them. And not much gets past Lyle. So now let's just check across that. Just check across this. So yeah, that's dropped even less there. So which it stands to reason. So have a look what's going across that screen resistor. That's not a lot. 7.5, so that should be okay. Yeah, that's fine. No problems with that. Well, they seem to be holding up all right. We've been swaging that now for a good few minutes. That's absolutely flat out on the scope. So yeah, we've been swaging that. We've got a 1 kilohertz sine wave through it there. So the first sign of these metal oxide resistors is the colours start to change on them. There, that's the one we're looking at. You can just about see it over there. Let's just go in a bit more. There, you can see it now. That's the one that we've checked. So there's 179 volts going across that. So if we square that and divide it by 10,000 ohms, that gives us, so that must be one hell of a resistor. And you do get some resistors, you know, we have a general size that most people look at a resistor and you get a general size, but there is some really, really high quality, high spec resistors that are, you know, are small, but they're still up to the job. And that is obviously one of them. Because if I put a normal, even a normal 2-watt resistor in there, that would have burnt up by now. It would have been blackened, because this, as I say, there's 3 watts. Normally you want about, that's probably about 4 watts, I would think that is. Might even be more, because normally in the Champs you have a 5-watt resistor, but that's not working too hard. But it's hot, it will be, it's getting swaged. So, but just things to check. Got a virtual centre tap down there, but you can't see unless we go. Don't think we can get the camera. Just pull the camera out. I think you'll just about see that there. There's a virtual centre tap there. Can't really see it. It's hard to get inside these things and see. We'll see. Let's just go over the top a bit more. There, we can see it now. So there's the virtual centre tap. There. And they've put the grounds in where this cap's grounded. There's the filament wires going onto it. Yeah, I think that's all right. So that's giving it a pretty good test. No issues with those. So yeah, it's all good. It's all good. Nice. So you've got the sprays. Just when you see the lovely spray capacitors, and then you see that there, kind of think, So it looks like they ran out of decent caps and just stuck that in as an afterthought. Would be interesting to see if that's in all of them. So yeah, that's pretty good. So we've had a good look in there. So I think we can switch off now. There's nothing alarming on the scope. So yeah, switch off the signal generator, or switch the amp off actually. So the only other thing I'm just going to do on this amp now, while I've got it down here, I'm just going to check the tubes, just test the tubes, but I'm sure they'll be all right. They've obviously, I'm not going to check the preamp tube because we already checked those. I think I checked those when Lee bought those. So yeah, I don't have a capacitor for that in stock, but I think we'll probably just leave that as noted, and probably just change it if we ever have to look inside this amp again for any reason. No big deal to change that, but I don't want to put a radial in there. It's just a no-no in this amp. So kind of wondering when this was made. That spray cap, is that the 3rd week of 2018? On there, 1803. Let me know in the comments. I never remember things like that. Like I say, I'm not one for, as I've said before, I'm not one for reading up on codes and things. I just mend what's put in front of me. But just let me know in the comments if that's the third week of 2018 or the 3rd month of 2018. I don't know. Or am I just talking waffle as usual? So just looking at the tube tester there, and if we assuage that button there. That tube's very healthy. That's the 6V6. So that's the Electro Harmonic one. He's a lumberjack and he's okay. So we need to look at the 5Y3. So just need to just look in here and see what we've got the book with all the different settings in there. 5Y3. So 8D2 and test is 4. And obviously 8D2 test is 6 because there's two sides of the diodes. There's two diodes in there in effect. Two sides of the tube, the rectification. So 8D2. Let's put the tube in. Warm his loins. Now obviously we're going to be on the bottom reading here on there. So, well, he's a belter. That's a Slvaynia. Yeah, very good. And 6. Yeah. He's also a lumberjack and he's also okay. So that's a result. And for anybody who does not know the significance of that, Monty Python. So yes. Right, we'll get those back in the amp. So there we are, we're running again. So here's the advantage of screening. You can see the foil on there. Look at the difference that makes. So I just thought we'd check the bias on this tube, and I've also found some more 6 of V6s. So I've got a KEN RAD here, 1957 I think that one was made, and let's just hone in on that, and you can see there's 717 and then 188-5. So I think the 188 is this was manufactured when GE took over KEN RAD, if I'm right. Let me know in the comments. If I'm not, that just put that down as my usual waffle. But anyway, so we're going to try that. We've also got a Slvaynia going on there. There we go. 6V6, but this is a Jan one, Joint Army Navy. And then we've also got a bit of a tatty looking Brymer, a bit of a Billy Brymer there. He's tested him on the tube tester, and he's okay. He's a little tired. He's had a bit of a hard life. He's probably been in a radio or something, I don't know. Right, so we're just going to check the bias, as I said, on this amp. We've got the original, the Electro Harmonic tube in there, which came in this amp. It's not original, but it's the one that's in this amp. Now I've got a meter up here that you can see, and we have 343 volts, and that's just going up and down a few volts depending on our mains voltage here in the UK, which is now hit 237. So 342, 343. That is measured plate to cathode. So if we look back down here, there you can see the probes. So I've got the positive of the meter on pin 3 of the tube, which is the plate, and I've got the negative of the probe on the live side of the cathode. So we're measuring the from cathode to plate. That's what we're not measuring from ground to plate, or plate to ground, should I say. So in other words, this will be on the chassis if we was measuring plate to ground, but we're measuring plate to cathode. And if you're not confident of working with these voltages, then don't attempt this. So there's my disclaimer. I'm just showing you how I'm doing this. That's my disclaimer. So we're going to measure across the 470 ohm resistor, which is the resistor that that's the cathode resistor, which is at the side of this IC cap, 470 ohm. So we go across, we go into there, and we need to just check that we need to set this, don't we? So if we set that, we'll set it to 200. And there is quite a bit of heat coming off that output tube. We'll just go in there, and you can see we've got 21.7 volts going across that resistor. Now the resistor, we need to measure it as well. We also need to write some of those down. So now we need to check that resistor. So we know it's 470 ohms, but is it 470 ohms? It's also had quite a bit of swaging. So it looks a little baked, but it's okay. And if we just check that now, so that's 462 there. If we look, you can see on the meter 462. So that is a little less than 470. So 462 R, or ohms, whichever you want to write down. So if you see R, it's usually low valued resistors. Anything usually below a K, you often see it written below 1K is 462 R. That R just means ohms, that's all. So let's switch back on. So we've got 340 volts plate to cathode. We've got 21.7 volts across the cathode resistor, and our resistor is 462 ohms. So some simple Ohm's law maths there will sort that out. So we take the 21.7 and we're going to divide it by 462, which is our resistance. That gives us 46.9 milliamps, 0.04696. So near enough there, 47 milliamps. But we'll go with the 46.9. Now, when you simply with that, we need to times that by the 340 that we have. So sorry, tip that. So times, I've done that, 3, 4, and there's our dissipation. And that tube is blasting away at a whopping 15.96 there, which is overbiased by 4 watts. Because it's near enough 16 watts. These dissipate at 12. So, and I did say to you that was swaging. So that is rather high on there, but that's the nature of these Fender Champs. They are biased quite high. They do that on them. I think that some of the others, the older ones, are biased around 17 watts, and it's to get the headroom, which is why they do that. Am I going to change that? No. And the reason is that Lee really likes the sound of this amp. So I'm certainly not going to meddle with the bias, but we thought we'd check it. But what I am going to do is I'm going to let him have a couple of these tubes to try in this amp. And we're going to try them as well when we demo this amp, just for a bit of fun. So yes, that's swaging pretty good, but as long as the transformer can take it, then obviously the tube's not going to last as long in there. But having said that, it'll probably, you know, if you're using this amp 6 or 7 hours a day, the tube would probably still last 2 or 3 years, if not more. You know, tubes last a long time. It's the only time tubes don't last long is when the coupling capacitors are leaking DC onto the grid of the tube. Then they don't last as long, because that just ups the bias even more. But as I say, it won't last as long if it was as what it would if it was biased at 12 watts. But it's the nature of the amp, and let's face it, there's millions of 6v6s around, and they're not expensive. But and the Electro Harmonic ones, they will stand the extra swaging, the extra, you know, being overbiased more. The JJs tend not to, in my experience. But the Electro Harmonics, which is why they put them in the Black Star Artisans and things, because they're way overbiased. But they do sound good. It does make the amp sound better. You know, as a guitar player, it does. So, you know, most techs that aren't guitar players, they're very eager to put that at 12 watts. And most techs frown upon overbiasing tubes. But they do sound better. They sound really good when they're overbiased. So people do that. And why not? You know, if the transformer's not up to the job, then it's not recommended. It's no good trying to do that if, you know, and generally the manufacturers that put these amps together, you know, they're not total dummies. They know what they're doing. So if you get one of these and it's biased at 12 watts and you wind it up to 16, the transformer's probably not going to stand it for long, because they've biased it. You know, it's been engineered, and they've looked at the transformer, and the maximum they're going to be able to get out of it is 12 watts on the tube. But that transformer will stand that all day long probably. It's been matched for it, so it's fine. It's just the tube doesn't last as long, and the tube will just get tired quicker. You know, it's not necessarily, the tube's not just suddenly going to blow apart or anything. It just get tired quicker. It's just being overbiased, but that's fine. If you know, if you want the tone, then you pay for it. You know, your tube doesn't last as long as you buy another one. Anyway, enough waffling on that. So let's unplug, and now we're going to try some of these other tubes in there when that cools down, of course, because I'm not putting my hands on that yet. So we'll be back later with another tube in there. Right, so we've got the KEN RAD tube in now. I had to wait a while for that to cool down. That was seriously cooking, and it will be, being overbiased. So if we look at the meter, we're just going to switch on. Oh, hang on a minute. Pull the plug out, force of habit. There we go, and you can see the plate volts there, 462. That's touch, 463. And then you'll watch it go down as the tube conducts. And that's going down quite a bit, 354. Little higher than the other one though. What did we have before? 340 before. So that's 350 and dropping. So we'll just give that a few minutes to drop. And then we'll see where it finishes when it's fully warmed up. There you go, and you can see it's now 355 because the wall voltage has gone up a bit. So it's about the same as what it was now, the wall voltage with the other tube as well. So we've got 355 volts there, we'll say. Now we need to get the voltage drop across the resistor. So we need to go down to here. And we need the other meter again, don't we? So what does that tell us then? Well, it tells us that that tube is not drawing as much current as the Electro Harmonic tube. Sorry about that. And this is back down to the thing again when people say, oh, cathode biased amps, you don't have to check the bias, just put the tube in, it'll be fine. But you can see that it isn't, although it's less, so it's not a problem with that one. But imagine if it was the other way around and you were critical on, you know, on biasing this. Let's get that to there. Pop that in there. What's going on there? We're not. What am I doing there? That's with waffling that's caused that. Let's try that. Let's try now. And you can see now I've only got 18.5 across there, so less drop across the resistor as well. So 18.5. So we know our resistor is 462R. So let's just do the maths on that. So we've got, as we look again here, so we've got 18.5. You see that? And then we divide that by our 462. Equals, now we can take 5% off of the screen as well, on which we didn't do on the last one, which we should do really. But you can see that tube's drawing 40 milliamps. So let's just now times that by 355, and you can see now that that tube is only drawing 14.2 watts. So that's not drawing as much current at all. In fact, it's probably less than that if we take 5% off of the screens. Take 5% off of the screen, 13.5. We should have done that on the last one. The Electro Harmonics one was 21.7 divided by 462 equals, and remember that was 46.9. So if we take away 5%, that's now 44.6. So if we times that by the original voltage, of which was 340, that's actually drawing 15 watts there, plate to cathode there, 15 watts, which is still high, you know, it's still well high. Right, let's try the Slvaynia then, see what he's got to offer. Right, there we go, 344, almost 345, I'd probably call that 345. Let's use our meter again, and let's check the voltage drop across the cathode resistor. 20.8. We know what our resistor is, it's 462 ohms, so we just need to do the maths on that. So 20.8 divided by 462, take away 5% for the screen is 42.7 milliamps. And if we times that by 345, 14.7 is what that tube's dissipating. 14.7 watts. Got him on the test bench on top of the 4x12. We're not plugged into the 4x12 yet. We've just got it on its own speaker. And we've got the Slvaynia tube in as well. So we're going to check these tubes out and just see if one of them stands out more than the other. That's the Slvaynia tube, and we've got the volume is on number 3, so I've got this pretty clean. Remember on the video it broke up after number 4. It's actually quite loud as well, even at that. So what we're going to do now is we're going to plug the 4x12 into it and have a listen to that now. Right, now it's on the 4x12. Much warmer tone now, Rusty there, in fact a lot rusty there. So that's it on the 4x12, and that's with the Slvaynia tube in there. Right, now we've got the KEN RAD tube in it now, so we're going to have a listen to that. And we're back on the Champ speaker. Well, that appears to be quite a bit louder now. Seems to be a bit of a fatter tone to me. Not always been a great believer in one output tube sounds a lot better than the other, apart from the obvious if one's really tired and one isn't, but we've tested these so we know they're all reasonably good. let's just try it on the 4x12 now. Right, we're on the 4x12 with the KEN RAD tube. Now that to me appears to be not quite as bright, more of a warmer tone and a slightly thicker tone. Oh yeah, that's a lot warmer. So that KEN RAD tube sounds really nice in there. That surprised me, I have to say. Right, let's switch off and we'll try the its original tube, which was the Electro Harmonics. Right, now I've got the Electro Harmonics tube in there. Seems even louder with that tube in there. I know all these three tubes tested, they tested good. The Electro Harmonics did have more emissions than the other two. It did go higher on the tube tester, although the other two are still perfectly fine. That is noticeably louder. Neck pickup. So that's got a nice full sound. It seems just a little bit more brighter and a bit more aggressive. That KEN RAD tube is a really mellow tone. Right, back on the 4x12 with the Electro Harmonics tube. This amp amp sounds awesome on this 4x12. So there we go, that's that on the 4x12, that's the Electro Harmonics. So the Slvaynia 2 to me is the least of the three of those. That's got a lot, that one seems to have a lot more power, that Electro Harmonics, but that could be just because it's simply a newer tube. But that KEN RAD is a very mellow tone. So what we're going to do now, I'm going to do one more test. So we've got the hot plate here. So we're going to try the hot plate. I'm going to crank this amp so I can get it on the hot plate, get the volume down. I'm going to have a listen to that. Right, so I've put the KEN RAD tube back in because I prefer that. There's not much to choose between the Electro Harmonics and the KEN RAD. Not keen on the Slvaynia. Well, it's not I'm not keen on it. I just prefer this this KEN RAD tube. So let's put these on so I can see what I'm doing. So let's start flicking up the dB. Now I can crank this amp. Bit of blocking distortion going on there. Now I've got the volume on about number 6 there. So there we go, and much more than that. Let's go to number 7. Number 8. And it gets a bit blocking distortion after that. So that's on the 4x12 cab with the THD hot plate. So let's now try it on its own speaker with the hot plate. You can probably see it on the camera. I've just had to put the hot plate, stand it on something and put it on its side for the cable to reach from its own speaker, because it's a very short cable. So let's go back to I'll put some glasses on, I can see what I'm doing. Blind as a bat. So we're on number 5 there. Dear me, dog, I'm rusty enough as it is without you pushing your nose into my hand. Get off with ya, you naughty boy. So let's go up to number 6. Seven. That's flat out. There's not really much change between 7 and 12. It's got 12 on it. And you can hear the blocking distortion there, and that's not very pleasant. So yes, a grid stopper needed there, and I'm sure if we put one in that would sound absolutely awesome. So yeah, that's a very nice amplifier, as long as you're not, you know, cranking it up flat out, and there's really no need, you know, you're going to turn this up where you get the sweetest tone, and that's probably about number 4 or 5, and you know, much over that, it's, as I say, you get the blocking distortion problem. But other than that, it's a lovely amp, and all the champs are like that. You know, this is you get some really tasty sounds out of this amp, and you think of the people that's used them for recording over the years on some of the most classic albums. You know, Clapton used one on a lot of his albums. So yeah, what a tool. So that's been a bit of a fun video there, more than it's not really been a repair as such. It's just a bit of a fun video, and I've quite enjoyed doing that. So we didn't get it all done on the night shift. I've had to do the demos, obviously. It's Monday now, so I've had to get the demos done today as opposed to the evening, because we can't be blasting this out at that time of night. I think it was about 11 o'clock by the time we'd finished with one thing or another. So there we go. So for me, it's the KEN RAD tube. I think is the best. You probably on camera, you're probably not going to be able to tell much difference, certainly between the Electro Harmonics and the KEN RAD. The Slvaynia had a much thinner tone to me. Still nice though. But yeah, cracking speaker in this amp. Really nice bit of kit. So that'll do it for this one. Thanks for watching. You all take care, and I'll see you all in the next one. Bye bye for now.